Cool. Yeah, so I'm an ecologist, and I've spent the last 20 years of my life studying and trying to protect this bird here, the Swift Parrot. And this species is a small migratory bird that breeds in Tasmania, down in the south of Australia, and migrates north for the winter. And I've always been quite fascinated by their movements, but we were never able to actually track their movements because of their small size, and we could only use a radio tag. So these birds were the inspiration for what my life has now turned into, which is all about technology and actually helping researchers all around the world improve the data collection, etc. So I'll share a bit of the background so you can understand where it came from, and then I'll get into a bit more detail about how it all works and how you might be able to use it in your projects wherever you may be. So as I said, this is a small migratory bird, and they feed on winter flowering eucalypts, so gum trees across eastern mainland Australia, and they migrate up just searching for it. But because we have such big drought and rain cycles here, that's highly variable, and these birds move across the landscape in really dynamic ways. Really fascinating. I did my PhD research on them. I've been employed to work on the conservation program for many years, and we know a lot more than we used to know. But one thing that has remained a mystery for this species is its movements. And it's a really major part of its life cycle. You know, like without the migration, they can't move between their breeding and their wintering areas. They can't move between different wintering areas as the resources change in a season. And people who tried to previously track them had failed. So these birds live at the tops of the eucalypt trees, that's where the flowers are, and so are quite tricky to catch in the first place. But some researchers in Tasmania did manage to catch some birds and tag them, but never found them again once they were let go. They do fly very, very fast. They live up to their name, and they were never, just really didn't know what had happened. And so that was the only experience that I had to base my desire to understand their movements on. So I'm like, okay, well, if this is what's going to happen, we really do need to find a better way of searching across landscapes like this one here, and being able to rapidly cover areas for these small birds with small tags. Many of you would have probably had an experience like one of these, and the sort of the extremes that people will go to find these little tagged animals that they have out there. Getting to a high point is the usual trick that people are trying to do, whether it be on top of a mountain, a car, a fence, or anything you can. A helicopter, if nothing else will work, or even if you just need a different perspective, jumping in a canoe can help you find that little ping, ping that you're listening for. You get very good arm muscles, but other than that, it's quite an excruciating experience if you're working in any sort of terrain that is in some way challenging. So when I was doing my PhD on this species, I had some colleagues who were working on lions, and they were also lamenting about the challenges that they were facing in tracking their movements, and if they wanted real-time data on where those animals are. Of course, bigger animals, you can have satellite and GPS tags, and there's pros and cons to different types of tags. But we both kind of thought, geez, wouldn't it be fantastic if we could just like create a high point anywhere with a drone? But this was about more than 10 years ago, and so there was hardly any drones around at that point in time in the commercial space, and so it was quite tricky to find anyone to work with. And more recently, I've been in discussions with people who work on species like pronghorns, incredibly fast animals, and needing to, although you can satellite tag them, if you want to know where they are right now, that the satellite doesn't give you that, and so that's where the VHF or radio tracking comes into it. So that idea kind of just sat in my mind, and over a number of years, I applied for grants and didn't get them, and then finally, the Laura Parker Foundation actually came on board and contributed some money, and we were able to get a linkage grant through the Australian government. So we spent a few years just seeing whether it was actually possible, like will the noise of the drone interfere with the technology? How do you actually do any of this sort of thing? So yeah, like hundreds and hundreds of flights. We started on a runway with just a tag on a pole, and then when we're like, okay, well that seems to be working. Well, I'm like, I really want to see it in a woodland, right? I want to track swift parrots, and this is the kind of habitat they're in. So we need to take it into that system. It's a more cluttered system, much more complex in terms of radio signals. So we started throwing tags up in trees and under logs and things like that, and testing the system out. And we actually found that, yep, okay, well, it looks like it's working okay. So we were ready to then, go find some swift parrots and tag them and see if we could track them. The only problem was that we couldn't attach a tag to a swift parrot. We had a couple of years worth of captive trials, and we tried all different types of attachment methods, different materials, different attachments, and it was just incredibly complicated. This bird actually rummages around in amongst the vegetation, and so they're very prone to getting entangled, and they also nest in cavities, which really they squeeze into, and there's sharp edges to some, like a bit of timber. And so this bird is endangered. We couldn't risk losing a bird to an attachment for a tag. So we were like, okay, well, we can't tag this species at this point in time. And we were looking at a long-term attachment. We really wanted to understand migration. So we just switched to just demonstrate that this technology could track a live animal. We then attached it to a local resident bird that was in abundance at the site. So we caught some of them and tagged them, and we're like, okay, awesome, like that works, that's fantastic. We were one of the first people in the world to be able to do this, so it was pretty exciting to be able to do that, although I was still disappointed about the swift parrots. There were some great things about this system. One, that we could prove that it was possible, but there were also a number of limitations, and we had this big project with lots of planning involved to track these gorgeous little creatures here. They're bettongs at Mulligan's Flat Nature Reserve, and some of my colleagues put in a lot of effort to make this sort of test happen. It was going to be like human versus drone test of the technology. The only problem was when we got out there, this was in Canberra and at a different test site to our usual one. And as soon as the drone got 10 metres off the ground, it was swamped by a massive radio signal, and we could not hear any of the tags. And I was just like, no, I've just spent 3 years on this thing. This was supposed to be the glorious moment where we could show everyone what we'd achieved. And we couldn't, and it was so devastating. But what we did realise is why that was happening. We had such a small and lightweight system on this drone, we couldn't add anything else onto the payload on the drone. It couldn't carry any more, and so there were some aspects of it that we weren't able to include that we would have wanted to. So things that filtered out some of these out of band signals. So we learnt a lot from that. We also found that it had quite a short detection distance. So it could pick up signals if there wasn't an interferer, but it was quite short. And we had to have really, really specific tag frequencies. And I mean, that's not that practical when people already have tags out there, or they want different combinations of frequencies. It just wasn't flexible at all. We could only do Australian animals, or in the 150 to 152 megahertz band, and it was a really short flight time. So you could only do so much in 10 minutes maximum flight time. So all of these things kind of really added up, and I'm like, oh, okay, well, we've proven it's possible, but we haven't really got that product that people can actually use. Although I was only really interested in my own research. It was just because I wanted a tool for myself. I had no grand plan about this thing at that time. But as soon as people found out that we could do it to some extent, then I got all these inquiries about, oh, could I get one of these, or how can I get one of these? I'm like, well, I don't know. My project is just finished and I have no more money, and I know about all these limitations. But these inquiries kept coming into me, and I was looking for, my next research project or what have you. So I just kind of took a bit of a different path down the innovation kind of thing. Started learning about how to actually translate a research thing into an actual commercial product, or one that I could get out that's usable by anybody, so that it could be used anywhere in the world. So I, a number of years later, all very compressed story over quite a bit of time, I just started exploring that idea, and we started applying for small grants and things like that. And then we were able to actually buy our own drone for the first time. I had to find a whole new team of people. The first team I worked with were roboticists, so that was fantastic. It was actually a robotic system, and it was very, very smart. But there's other sort of constraints that come with that in regulation, as well as the type of drone that you can use. And it was an incredibly expensive drone, all those sorts of things. So we actually moved away from a robotic system to simplify it. So we could really focus on the radio tracking elements and get that part of it right, with the aim of being able to attach it to an off-the-shelf drone that anybody could access. And now we've managed to pull together engineers, industrial designers, and the like, RF engineers, and I'm really excited, because it's like all of those things that I kind of was like stopped us in our tracks in that first project. We have now overcome, and we can not only track 1 but up to 40 animals simultaneously. So that's typically more than what people will have tagged in a project at the moment, just because it's so labour intensive to do the tracking. We have much better detection distance than we ever did before. And we now have real-time data feeds. So while the drone is in the air, the data is coming down to a laptop, and you can see the signals of the tags, you can see locations of the animals in real time. We have a lot smarter algorithms in the back end, so we can deal with some of those interferers. And if we're still there, there's other techniques we can use to minimise their impact. I think if you've done radio tracking, there's typically 1 or 2 animals that you can hear some noise or somebody talking or something, which really interferes with your capacity to track them. So there's some tools that we can use to get around that. It also can be used on any VHF band now. So not just what we can do in Australia, but anywhere in the very high frequency band range. Within 2 megahertz, we can track all the tags within that area. And we've also discovered that we can actually also download close proximity GPS data. And this was a real bonus for us, because as tags get smaller and smaller, there's, GPS tags can be really tiny now, but being able to get the data remotely, you still do need to be close to some of those ones. And we found that with just a small adapter, we could attach our antenna to a third-party download system and not only track the animals, but we can then also download the data without having to go near the actual animal. So that's a very quick rundown on the sort of the journey to sort of where we are now. So I'll talk a bit more now about actually how do you use this thing. So first of all, you can tag your animals with whatever your preferred VHF radio tag manufacturer. Most species, or most people who've worked on species, have a preferred supplier and a preferred attachment method, and it doesn't matter to us who makes them. If it's in a VHF band, we can track it. So there's no need to buy any particularly special tags. They all have their own unique frequencies, and we can track them at the same time. So we've designed our system to attach to a DJI drone, the Matrice 210. It is a bit bigger than your sort of hobby level drone. It's in more of a professional grade drone. And the reason for that is just the lifting capacity and flight time. So it's a really fabulous machine in terms of being able to carry about 1 kilo, which is what our payload weighs. When I say payload, that's the radio receiver and the antenna. And the idea is that it actually just screws onto the top of it. The antenna just attaches across the legs, and then you launch the drone. When you do launch the drone, you can use it in a couple of different ways. So a lot of the time people are actually really keen to find lost animals. So if you have lost an animal and you just really need to search big areas, like what I was describing for the Swift Parrot, then you can simply fly the drone around the area. It's a directional antenna, just like you are doing with the handheld in a way. So you can point the antenna up gullies or down valleys or up over ridges and things like that, and really just do a big sweeping arc and survey quite big areas very rapidly. The other, and you'll see a peak on the interface where whenever a signal is detected, you will actually see it on a chart. And then if you actually want to get a location, like sometimes just finding them is enough, or just knowing they're still in your study site is enough. But the other thing you want to do is actually find a coordinate of where that animal is. So in that case, you would launch the drone, slowly rotate it. And so you're taking signals from all directions, and then based on the signal strength, you'll get a bearing on a map, and I'll show you what that looks like in a sec. And then you move again, and you're essentially triangulating, but the drone is doing all the legwork for you, so it can go here and here, and then very rapidly be able to start to get a fix on where those animals are. And as I mentioned, that's all displayed on the laptop. So this is what our user interface looks like. And I was going to show you the actual system itself. I've got one sitting here, but I'll show you at the end what it looks like. So this is, we provide the radio receiver, the antenna, as well as a laptop. So you have everything that you can need, and we can ship it off to people to use on their own drone, so they can go and do the flying themselves. In Australia, we also offer services, so we can actually go do the tracking for people if they would like us to, if they don't have a drone or a pilot that they can use. But we have a Pelican case essentially that has a laptop and all of the gear in it, so you can just open up the box and it will work out of the box. And we've designed it so it's as user-friendly as possible. So on the left-hand side, we have a whole range of buttons, but we've broken it up into different sections. So you've got a couple of buttons at the top, which actually, when you're creating a folder with those buttons, and so that's where all of your data will be saved at the end. And then we have a pre-field and in-field section. So before you go out in the field, there's just two things you need to do. If you want to use our maps, you can download them when you do have connectivity in your office or wherever you are, and then they'll be available offline. So all of this system works offline. You don't need internet connectivity once you've got some maps, or if you have your own maps, you can actually upload those as well. So you don't even need internet connectivity if that's the case, and then input the tag frequencies. So traditionally, when you're doing the handheld tracking, you get each of your tags, you turn them on, you fine tune your receiver to the best one so you can hear it clearest before you put it on the animal, and then you release them, and then you go through and track each animal one at a time. With our system, you don't need to do any fine tuning, because a little chart pops up across the bottom of the map. I can't see my cursor, and a chart pops up across the bottom of the map, and it actually it's just a signal strength chart. So you have all of your frequencies across the bottom, and then just how strong they are. So as soon as the drone is in the air, you can see a peak coming up, and you know that you've got those tags and that they're nearby. And so you can even hover your mouse over the graph, and it will tell you exactly what frequency the peak is at. So if it's drifted 1 or 2 kilohertz, it doesn't matter, you're still capturing it. So before you go out, it's pretty simple. Enter your tags into the user interface, or you can upload a CSV file, and then you're ready to head out into the field. When you get out there the first time, and calibrate the payload just so that the magnetometer in there is ready to go for your particular site, and then you just send the tag information to the drone and you push start tracking. Once this line here on the there's my cursor. This line on the map here is actually an outline of an area that you've downloaded offline, so you can actually see the area, and you can just keep downloading until you've covered as big an area as you need. And you can also choose between a topographic map or a high resolution satellite map. So you can use either of those. And I find in really mountainous terrain, you can't beat the topographic map because if you're getting signals from a particular area and there's ridges and things, you can really narrow it down to particular valleys or what have you. So that can be quite handy, but they're just interchangeable. You can use whichever you prefer. So once you've launched the drone and it's starting to rotate, and you've got an idea of the signals in each direction. This here, where you can see all these arrows radiating out, each one of those is an individually tagged animal. This is actually some data from a project we did in New Zealand on Kakapo. On that island, they have like 99 animals tagged, in fact, but they're obviously not all in one spot. So we went up on one side of the island and we input 40 tags and launch the drone, and that's all of the animals that we were picking up signals at the same time. So you can see most of them were in one direction, only a couple in the other, and the reason there was only a couple in the other was because there was a cliff face over that way, so there's only so much room that you can have there. So once you've done that first rotation, based on the direction of those arrows, you can then decide where to go next to get the optimal intersecting lines of the different bearings. And as soon as you start to get intersecting lines, you start to get points on the map. So you just need a minimum of 2 lines to start to get an estimate. And if you do more rotations, you can refine it again and again. So on the bottom little insert here, you have the points on a map, as well as some circles around those points. So you can click on each of these points. It'll tell you what tag it is, what the coordinates are, and also give you an error estimate. So the error estimate gives you a feeling for just how accurate that point is, and you can see there's quite a bit of variability there, and that's an inherent part of radio tracking. So some of them might be under a log or under a rock, or just might be moving, and so the signal is not the best, so you'll get a bigger error, but you will get that coordinate, and all of that data is appended to a CSV file while you're in the air. So in real time, you can see where these animals are. And once you feel like you've collected enough for that particular spot or those animals you were looking for, when you push stop tracking, it's automatically saved in a CSV file format in that folder that you specified at the top. So all your data is there. You can back it up on a USB stick. You can put it into any other program that is useful. Down on the bottom left, you have this sort of compass looking icon, and this is actually a guide for the drone pilot. So with the rotations, it takes about 2 minutes to do a really good rotation. And it takes a bit of skill to fly that slowly for 2 minutes. And so we've provided a guide there, and basically that black line, the compass needle, if you like, actually moves around as you turn the drone, and it colours in the circle. So once you've coloured in the whole circle, you know that you've got enough data from all bearings and you can move to the next location. And that's when it does all its processing and displays it for you. So I actually can't see, I just realised that you said to sort of put up questions, but I can't see any questions on my screen. So
no, don't worry, Debbie. I'll facilitate at the end. So just keep on keeping on.
Keep on rolling. Okay, yep. Cool. So I just wanted to give you an example, I guess some examples. So in the end, we did end up tracking Swift Parrots, and we could only do short-term attachments, but we actually saw some research on some seabirds where they were using tape to tape it to the feathers on the back of the bird. So we did some trials on that, and it was brilliant because we could attach it to the bird and they actually would chew it off over a period of time. So we would get a nice period to track them in, and then all of the tags were falling off and we could retrieve them and know that those birds weren't encumbered with them when they then had to migrate and go into their hollows. So that was great. And some of the fantastic things that we were able to discover was where their roosting sites were. So these birds will forage in groups across the landscape, and they often will come together and communally roost. And we've discovered new sites for this species in terms of where they're gathering. And you can have up to 10% of the population gathering at these points. And it's incredibly exciting. And they're always on private land, it seems. And so they're not currently afforded protection. I also have another conservation project for the Swift Parrot, where we have money to give to landholders to protect those habitats. So we've been able to actually follow up on the data that we've collected from this bird and make some really positive difference on the ground in terms of conservation. We're getting areas protected, get conservation agreements on them, revegetation, that type of thing. So for me, that's been really rewarding, that my research has then actually contributed to some making a difference on the ground. So that was the first species that we did track once we had our new system developed. We then, I don't know if you can see this thing at the top. I'm trying to get rid of it, but I don't know how to get rid of it. I don't know if you can see it or not. Anyway, then we went out into a local national park, and we radio tracked Rosenberg's goannas. These are, well, probably for most lizards, they're pretty huge, and they actually have a GPS tag that they were using, a VHF and a GPS tag. You can kind of, I think you could see a bit of an antenna coming off the back of this one. But one of the things that these goannas really love to do, they're really shy and don't really like being around people. And so when you're tracking them manually, they will like want to dive down the nearest wombat burrow, like a big hole in the ground essentially. And the people doing the research found that it was right when they go down the burrow, you can't often get the GPS data. And so then they have to just sit there and wait for this animal to emerge from the hole. So we had a go at not only tracking the animals, but also downloading the GPS data. And this is one of the examples where we discovered that this was possible from the drone as well. And we even, it went underground on one occasion. I wanted to actually see one because I hadn't seen one up close before. And we found one, but it dived down a burrow again. So I ran back and flew the drone while we knew that the animal was actually underground. And it was really great because we also found out that we could track them even when they're underground using the drone. So for me, that was kind of mind-boggling that could happen. So that was quite exciting as well. This was quite early on in our journey. You might notice that the attachments on the drone do change over time in these photos as we've got different antennas, different receivers, all sorts of things that we've changed over time, every time we improve it. This is from a project we did down in New Zealand. It was a trial project just to see how this technology went. The kakapo live on this rugged island off the south of New Zealand, and it's really dense vegetation, very, very wet, very rocky, and these animals are typically down low on the ground amongst logs, or they can be up in the vegetation as well, but typically under that dense canopy. And so we thought we'd go and test it out down there. And it just blew my mind away because it was it was just exactly what our system was designed for, where you have lots of animals tagged. And within 1 hour of like the drone flying in the air, we had done the equivalent of 4 days of manual tracking. And then we actually flew for more hours. So it was the equivalent of, more than a week's work done in the matter of 2 to 3 hours. We were able to track about, I think it was up to 19% of the entire population at the same time. And so it was really great. And I was very fortunate because we were also able to, make sure that we could verify the locations that we got. We went and found one of the birds and we were actually able to meet them, which was super special. Very charismatic birds. Very different landscape, actually close to home here in Canberra. We had a horrific summer where just extensive areas of Eastern Australia was torched and incinerated. And it is still quite a shocking scene in many places. And this is an example. You can see the burnt landscape on the left there, where they're really, even 6 months after the fire, there was not a skerrick of revegetation. There was nothing on the ground. It was just ash and charcoal, because that area was also in drought before the fires hit. So you can imagine the impact. There's a koala sanctuary there, the Two Thumbs Koala Sanctuary, but also further afield, other wild koalas as well. So there's a project that Australian National University and the New South Wales government have to track animals both in the burnt and unburnt areas. And they called us in to help search for some lost animals. So they were unable to pick it up with the handheld, but it's quite rugged, and there's actually like some rocky, really steep rocky faces that are really difficult to get to on foot. And in a day, we were able to survey up to 5,000 hectares and be very, very confident that those koalas were not anywhere in there. We could actually pick up the ones that they did know about everywhere that we launched the drone, and we never picked up those lost animals. So hopefully we'll be able to get back and actually search further afield and see whether these animals have gone off. But we're not sure whether the tags might have failed as another thing. So we're actually heading out there next week again, and we're going to be trialling out some different thermal cameras and do some thermal surveys there to see if we can find those animals that I think the collars might have failed on. So that's a really nice one for us, because I think everybody on the east coast of Australia was impacted by these fires. So it's really nice to be able to help out with a project that is really trying to understand what's happening there and help them cover some pretty serious ground. And we have another project which is very dear to my heart, in that, again, it was another one where the Save Vietnam wildlife team asked us to head over to Vietnam and just see if this would work. And to be honest, I didn't know if it was going to, because again, incredibly wet, incredibly dense, and these animals can be underground underneath all of that. And so we sort of made it very clear that we just weren't sure. So we'll go over there and we'll try it out and see what happens. So we did a couple of trials and we found that it was fine. And we're, oh, okay, well, let's go for it then. So we went and got some of those animals that have been rescued from the Chinese medicine market, and released them, and then we began tracking them. And this organisation, they have hundreds of these animals every year that they rescue and rehabilitate and release, but they've never been able to really demonstrate the contribution that they are having to conservation for the species. They don't know what happens to them a lot of the time. And the reason they haven't known that is that they were sharing their stories of what they have to do to find these animals. And they can have a team of 3 people going for 3 days and never find one animal. And it's just incredibly prohibitive. And all hats off to them, for they have the most amazing persistence. I looked at that landscape and I just don't think I could even traverse it. I mean, maybe it doesn't even look that bad in that photo, but when you're on the track, it just looked vertical. Anyway, they can now release more animals than they have ever before and track them all at the same time. So we went over there last year and set them up with the system, and they've now been using it for quite some time, and we work quite closely with them as well. And as we develop our system, we've been upgrading theirs and the rest of it. So that's a really fantastic one that we've really loved being involved in. So you can see, like, different people have had different problems. Some of the landscapes, some are just they've got so many birds that they need to track, or there might be access issues in terms of there's some on private property, but you don't necessarily even need to fly over that private property if you can get a signal. One of the things that I think differentiates our drone technology from just about all the others is that it's not visual, because it's listening. And we actually want to get directions and bearings. We don't want to go close to the animals. We don't want to disturb their natural behaviour. We're trying to study natural behaviour. So we always like to keep away from the actual animal and get the coordinates that way. And by by actually spending some time doing the aerial tracking, it saves a lot more time. So if you do need to go to the animal to replace a tag, observe the habitat, observe its health or well-being, you actually have that opportunity to spend your time doing those things which are really valuable rather than just trying to find a location. So that's kind of my thing, and so yeah, I'd be really keen to hear about different people's experiences or what have you, and yeah, have a discussion more about other things that are going on in the world where maybe this tech might be of value. Thank you.
Wonderful. Thanks for that, Debbie. Okay, we've got a whole pile of questions coming at you.
Okay.
But before we get started, do you want to stop sharing?
Yes.
So
now I can see. Yep.
Yeah, there we go. And everyone, if you want to, you can change who's displayed by pinning by pressing the 3 little dots next to Debbie's name if you want her to be big. Anyway, first up.
No, don't make me too big.
Okay, sorry. Well, I mean, we can have the group. It's fine.
Whatever you want. Yeah.
I'm sorry, I'm micromanaging today. Carlos, do you don't usually have a mic, so I'm gonna jump in if you don't want me to read it. So Carlos is asking, Debbie, are you or do you know if anyone is using autonomous drones in their projects, like with no human control ever? Carlos, I can't remember where you are. It's somewhere in South America. But they're banned even in non-populated areas.
Yeah, look, I think typically the if you have an autonomous system, they like you to fly it only if you can take over with a control. I think as the technology advances more and people have more confidence that nothing bad is going to go wrong, then it'll become more commonplace to have that autonomy. And so our first system was autonomous, but we could just hit a button and regain control. So it is possible to do it, absolutely, but whether you're allowed to do it is another thing.
Sol, do you want to jump in?
Amazing book, really interesting.
Hey, Sol, you're very muffled. Can you talk closer to a mic?
Sorry about that. Can you hear me now?
Okay.
No?
Oh, is that better?
Sorry. You can hear me.
Maybe the question could be written.
Okay. Yeah. So what Sol's asking is, firstly, amazing work. Has this worked for small below the skin tracking tags, like reptiles and stuff?
So we haven't tried it with those at this point. The smallest tag we have tried is a microbat tag. So we got the 0.8 of a gram, and we could track them. They weren't on a bat. I'll have to put that out there. I can't wait to try it on an actual bat that's just going nuts around and see what we can do. But we wanted to see at least how far away we could get those sort of tags, and we could get them up to 600 meters away on a 0.8 gram tag. So I think I think those subcutaneous tags, they actually have the antenna external to the body, or is the whole thing internal?
Sal, do you want to type an answer to that?
Anyway, I think basically if the antenna is external, you generally get greater distance. But again, we have actually tried some giant armadillo tags. So they're big, but they are an internal tag that is designed to be implanted, and the people in Brazil who wanted us to do some testing, they sent us these tags, and we actually attached them to they wanted us to bury them underground essentially and see if we could track them. So I put them on a bamboo pole, and I stuck them down one of those wombat burrows, and I measured it, and it was like 2 meters in, and we could get the signal as well. It says implanted tags are mostly passive, which require close proximity.
So I was looking for he doesn't have experience, but he's interested in it for primates.
Oh, okay. Yeah. Oh, yeah. Look, I think we did have an inquiry at some point from people working on orangutans, because they were saying they couldn't put any external attachment, so they had to do an implant, and GPS and all these others don't work inside the body. So VHF is the only way, really, I think, to track them. So I think absolutely any VHF tag. The one thing that really does stop a signal being received is in the marine environment. It can be tricky. If the tag is immersed in salt water at all, it dramatically reduces its ability to be detected. But if it is kept above the water, it can be detected. But I think whether it's subcutaneous or not, as long as it's emitting a signal and it's a big enough signal that can be picked up, then there's no reason why you couldn't use it to track that.
Awesome. Okay, Julian, you've got 2 questions. Do you want to jump in?
Sure, thank you. It was really neat work. I love what you guys are doing. It's and you guys are, seem like you're pioneering this in terms of the interface and a lot of those. So it's really neat.
Thank you.
We I love it's an Antipodean country as well. So I'm from New Zealand. I'm from New Zealand originally, but
awesome. Yeah.
I'm here in the States at the moment. So
okay.
We're working on a similar project to be able to localize and then download data off a low-tech tag, the GPS data. So it sounds like very similar to what you guys are doing. Our approach has been slightly differently because we want it to be fully autonomous. And we're using a kind of a long endurance fixed wing VTOL aircraft. So it'll be able to fly for 2 to 4 hours.
Excellent. Which one are you using?
We've got the Albatross.
Okay.
Which is it's built in Texas, but it's a pretty low cost system. I mean, the whole aircraft is around 10 grand.
Okay.
So for its capability. But obviously with the fixed wing, we've had to go for a slightly different approach because it's difficult. Initially, we started out trying to direction find from 2 antennas and localize. We could fly over the top of the animal in orbit, but we ran into the same kind of issues that you're having with the range, the detection range on the tags. And the aircraft is obviously flying at 20 meters or 40 mile an hour, so you don't get a huge amount of wiggle room to actually localize. So I'm kind of wondering if there's any way that you could use your system and have 2 antennas to actually feed off separate radios, so you can fly these kind of parallel flight lines, and then use those kind of plots that you've got for positions to actually post-process, on a Pi or something or rather, to extract those positions from those triangulations on the flight lines, and then go back in orbit over those areas.
Yeah, look, at the moment we're doing this sort of stop and rotate business, which is it feels a bit strange when you got a drone and people are used to zipping around with a drone, and we're going, you have to go really, really slow in a circle. But I think eventually we would actually like to not have to do that rotating, and so you can just fly around, and that's where I think, we're really interested in eventually also doing it on a fixed wing platform. I think in the agriculture sector that can be really valuable as well. And the other alternative is to not have a directional antenna on a fixed wing, is to just have a monopole or something like that, where you're just actually, you might just do your standard, you'd have to fly everywhere kind of thing and do your standard grid pattern flights, but you would then maybe get a heat map or something like that rather than specific points. So it's kind of accuracy versus speed versus area covered kind of thing. So I think it'd be really neat to kind of, if you could search a massive area with the fixed wing and get an idea of where the various things might be if you have a really big project to work on. And then you could get the multi-rotor to go in and just nail the actual locations of the animals. So
yeah, that's kind of the approach that we've actually fallen back on, just given the range. We're actually just I think we're looking at using like a hoop antenna mounted under the aircraft, then actually just recording the tag ID and signal strength. And as long as it reaches a certain threshold above which we know we can get a download link, then we'll just get the aircraft to go back and orbit over that position, and wait for the uplink and the data to be transferred and then carry on. So it's slightly different in terms of, we're more interested in actually downloading the data off the tag. So we just need to get close enough to get a link rather than necessarily getting a precise position off the tag itself.
Oh yeah. Well, so we have done some of that with cat collars, the low-tech cat collars, and we were able to download the data from further away than they've ever been able to on the ground. But that was attached to our antenna, which gave a bit more range. But yeah, that's right. And actually, we're going to be doing that for the koalas next week as well. We'll just be putting it up because we can pick up the koalas from anywhere on that site. We can just put it up in one spot and get all the data. We don't have to actually go around and try and find each animal and get kind of close and download it. So yeah, there's certainly some huge benefits in that. Yeah.
Okay. I'd like to speak to you more about that.
Yeah, absolutely. I think probably my details will be available.
They're in the cooperative doc. Do not worry.
Awesome.
Hey, Julian, who are you working with at Duke? Are you at Duke Marine UAS?
Yeah, we are. Yeah.
Okay, cool.
Yeah. So we're working with Walter Sedgwick from WCS, and his team. The project's actually with their team out in Indonesia. They want to do some radio tracking on these endangered maleo birds. So they come and nest in the sand on the beaches, but then they disappear into covered dense forest or the jungle. So it's really difficult terrain, and potentially not a lot's known about their range. So there's potentially large areas to cover, and that's kind of why we went for the longer endurance aircraft to try and get this bigger area. And obviously, you could then translate that to other species in that as well, of course. But
absolutely, yeah, I think that's it. I mean, any of these systems, it's whichever animal it is tagged. It's not species specific generally, which is great. That's what I've really loved is I've done my own research on one species for so many years, and now I get to talk to people and help people with all sorts of cool stuff, and they're always amazing projects. So I get all inspired as well by what everyone else is doing. We just kind of try and help them do it a bit easier.
Yeah, that's my favorite thing about working with Wild Labs as well. Okay, I'm going to move on to the next question. It's from Paul in France, who doesn't have a mic. He's got a question about RF. Have you looked into using Bluetooth Low Energy or LoRa instead of VHF?
I haven't, and I guess what I wanted to do, my first aim was to use existing technology that's widely available and relatively affordable, and find a way to detect that better. So I didn't kind of set out for a new way of tracking. I just kind of wanted to harness what was already commonly in use and find a way to track that better. It's not to say other ways aren't possible. What I like about this over, say, a LoRa system is its flexibility, because the species I worked on was never in the same place between years. It might go back to the same place, but it might be 5 years. And so having a tower system that's built in a particular location was not very valuable for us. So it was the flexibility that I really liked with the drone for deployment. But yeah, I mean, I think it depends on what you're looking at and what it is you're trying to get out. I think all of these different systems have their own value proposition for different species in different sites. Yeah.
For sure. Archie wonders if this system could be adapted for fixed wing drone VTOL systems that could be used in some use cases.
Yeah, so that's the vertical takeoff and land. So that's okay. Yeah, absolutely. I think that's definitely something we'd like to do. This is, I guess, the first iteration, and I do think that that is the next step is to, we could actually use exactly the, I can actually show you now. So this is our, I don't know how big you can see it, but this is our radio receiver. So it's actually quite a small box, and it just has 4 screws, and it just screws into the top of the drone. So it's relatively small. It's got a bit of weight to it. It has its own battery and all its own sensors and things like that. So we actually make them ourselves here in Canberra. And then there's an antenna, which is a bit longer, but it is this, and it has some elements that come off it. In my mind, in terms of getting it onto any sort of fixed wing or VTOL drone, is really the challenge, I think, is in the antenna. To make sure it's aerodynamic and can go. But there's some pretty cool materials out there now. I'm really excited about exploring when we get to that point, that you can use on the fixed wing, which will act like 2 antennas. And yeah, some of this stuff is used in the military and is not sort of necessarily that available yet commercially, but I think it'll be pretty exciting when that new antenna stuff comes out.
Hey Rob, do you want to jump in? I assume you've got a mic.
Hi, Debbie. Amazing stuff. I'm sad I haven't yet had a chance to talk to you. I'm just up in Brisbane.
Oh, okay. There you go.
Yeah, I just had a quick question. Have you had anybody or you yourself worked on the sensor gnome system at all? You know, the little coded VHF tags. Is that something that your system could work with potentially?
Not really. And the reason, well, we would be able to pick up the signals, but it would confuse our system because our system is looking for unique frequencies, and the coded tags are all on one frequency, but they have a code embedded in them. So when we're getting a direction and you have tags in opposite directions, and we're getting a maximum signal this way and a maximum signal that way, it's going to be like going, well, I don't know. I don't know where this thing is. So yeah, I have been asked whether it would be, I'm kind of curious as to whether it might be possible to actually change our system a little bit to be able to decode the tag as it's tracking, and therefore you'd be able to identify different ones. But it's not a direction we're kind of going with at this point. We're just sort of focused on the unique frequencies, but it's an interesting one.
Yeah, I would imagine a few people would be interested because the coded tags are tiny, like 2.2 grams, and there's rumours that they're going to be even smaller soon. So
yeah, I think one of it again depends on the question that you have. So I know some people who are working on projects with the coded tags, and they have the towers, and there can be some frustration as well because they don't actually get locations as far as I'm aware. They kind of get, oh, it's sort of between these 2 towers, or it's kind of over here. I could be wrong. I've never worked with them, but that's from talking to people who've used it. They actually have contacted us and said, oh, I wish I could actually get a location for where this thing is, because if they need to go and actually observe the animal or change its transmitter, the location accuracy isn't there. But I mean, maybe that will improve over time. I'm not sure. Have you used them?
I've done some very basic experimental work with them for a colleague. I think there's a team at Darwin
yes,
that are
they're the ones who are asking me.
Yeah, right. So I think they've been working on some triangulation stuff, but I don't know whether they've nailed that yet. But I imagine that's not an uncommon question that people have.
Yeah.
But
But if it's just presence, like if you just want to know they're still in the area, then it addresses that, you know. But if you want to know specifics about the habitats they're using and things like that, then it might not be at the right level.
Okay.
So yeah.
Thanks very much, Debbie. Awesome.
No worries, my pleasure. Thank you.
Debbie, do you have a hard stop at the hour?
No, not really. It's just sleep.
Got piles of questions, and I'm wondering.
Yeah, no, let's keep going. I'm enjoying it. It's good.
Okay,
Thank you.
All right. Sophie, do you want to jump in?
Hello, everybody.
Hey.
Thank you all for this interesting discussion. So I am Sophie. I am working at CLS Argos. So I think a lot of people in the audience know this satellite system. So I understand that you are working at a little scale. With Argos, you work at a larger scale because you need to track the animals, the migration of the animals. So I understand with your drone, you are looking at smaller scales. But however, I think that nothing. I think that this system can work with an Argos tag also. If you put an Argos goniometer on board your drone with an antenna, but you will need some development, okay, and but you will be able to recover to detect your Argos tags, wherever they are. So this is my first thought about using Argos in your use case. And the second use case, maybe, I don't know if you have thought about a backup system to recover your drone in case of loss. And one solution could be also to integrate in your drone a little tag. And for your information, we have now very little chipset which will be compatible with the future Argos satellite system, which is already compatible with the actual Argos satellites, which are 8 at the moment. And in 2023, you will have 25 nano satellites Argos. Mm-hmm. And so we are developing new use cases of Argos. So I wanted to inform you, the audience about that. And if you have some question, I will be happy to answer.
Yeah, cool. I think, yeah, it's been interesting for me with just developing our system. I work on small animals, and so my focus was always on small animals, but it constantly surprises me when I get inquiries, you know, like the orangutan researchers or moose or pronghorns or bears and pigs and all sorts of things. And you can attach these satellite tags to these animals. I think the issue is if one of those fails or what have you, and then that's where the VHF, there's often VHF incorporated with satellite tags. And so you can either recover tags that are no longer actually transmitting to the satellites on some occasions. We had some researchers working on Tasmanian devils who inquired about using our system early on, and they had a quick release mechanism on the satellite tag so that, oh, not quick release, a slow release, so that it will eventually just drop off the animal. But they didn't quite get the drop-off mechanism right, and so they were falling off as soon as it rained, and they were coming off down inside den sites and things, and they couldn't locate it because it was like near a swamp or something. So there's other reasons for having VHF in with your satellite tags, but also for that real-time information when something like a pronghorn might move 100 kilometers or something in an hour. I don't know, but that can make a big difference as to whether you actually find that animal or not. So it is an interesting one, although I'm kind of a bit cute. I don't understand the suggestion of putting the satellite tag on the drone. Is that just so you don't lose your drone?
Yeah, it is a kind of backup for your link between you and your drone. It is a kind of backup if your VHF link is not working anymore. You can receive the Argos messages by satellite, you know.
Yeah, I actually think that in some of the Arabic countries where they have falconry, I think they have little tags that they put on their drones when they're doing something or other. And I've seen people tracking their drones with a radio tag, and you can buy radio tags to put on your drone. I have lots of radio tags, so I could probably just glue one on, I think, and I use another drone to track it if I lose it. I don't know, but yeah, I think it's good to have backup systems, and if you're doing really extended line of sight or beyond line of sight work, then I think probably tagging your drone would be a really good idea.
Okay. Thank you.
No worries. Julian, is Julian who's in number 10, is that the same Julian as before? Julian Dale?
Yes, hang on.
Are
Yes.
you sneaking in?
Sorry.
Okay. All right. You're on now.
Oh, yes, I was just going to check. With bolting your system onto various aircraft, have you got any onboard kind of filtering that you can tune to deal with the the different RF interference that you're going to find on different aircraft?
We have filters built into it, so anything that's sort of out of band is largely filtered out. So we haven't had any particular issues with interference from the drone with our system, only from external sources that are really powerful and that swamp most little radio tags that are out there. Yeah. Okay. And that's only if those signals are coming in at the frequencies where the tags are. So when we input tags into the system, we actually search for a little window around that tag to allow for that drift in the crystal. That radio tags have a little crystal in them, and sometimes they do drift a little bit. And so we allow for that by sort of searching through a little window. So we only have issues with interferers when they appear in that small window right next to the tag. And often people can, as I said, they can hear that even when they're handheld tracking. You can hear this buzzing or hissing or something, and sometimes it can be bad enough to sort of stop you from tracking the animal.
Okay, yep, fair enough.
Yeah, cool.
All right. Liam, do you want to jump in?
Hi there. Is that working? Yeah. Okay, good. First of all, thanks a lot, Debbie. It's really interesting.
Pleasure.
I'm working with drones to look at sea turtle aggregations in Greece. We're not using VHF, but it was really cool to see the way that you were putting it together. Anyways, I was curious. You were talking about looking at the migration of the parrots at the starting. I was wondering if you had gone further with that once you developed your system, or if you any plans to do migration in other species or anything like that.
Yeah, look, we haven't managed that yet. The best we've done so far, because the tags won't stay on them long enough to do the migration. So we've only been able to do them like within the wintering area. So it's still that ambition. One day I'm gonna hopefully do that. I think it'd be really interesting to do, like, I know there's studies from quite a long time ago in the US where they were tracking small passerines across the country by driving and getting up on top of the truck and things like that. I think it would be awesome to do that with some of these small migrants and be able to sort of follow them easier, if you like. It'd be good if you could just do like a follow me for the bird, with a drone. You don't want to harass them, I think, is the problem. You don't want to change their behavior. So I think there's all sorts of exciting possibilities that are sort of limited by your imagination if you had the right people with the right tech skills together. Yeah.
Do you think the plan for that, because of the battery limitations, would be like you mentioned, like taking off and then landing and then going to a different location, taking off and landing, or is that how you plan to do it?
This is how when fixed wings come into their own, that they can fly the distance, and I think it would make the job a lot easier, because if they're migrating, you're not actually trying to find a specific point, because they're not at a specific point. So you would be and you just kind of got my thinking now. I'm thinking about like our map with the arrows coming up, and you it just keeps following the arrows, and maybe you could do that. That'd be awesome. I don't know what the flight permissions for that might be somewhat challenging. Probably the most challenging part, in fact.
Yeah, hard enough already. Anyways, thank you very much.
Oh, thank you. That's a great question.
So the next question from Miguel is one that we see come up in the forums quite a lot, and big discussion. It's around the impact of drones on wildlife and behaviour. Drones are usually very noisy. Do animals run away in your experience? How do you fly high enough that they don't disturb you? How do you manage the impact on different species? And again, it's probably going to be species specific, right?
Absolutely. And I think Yeah, it's great. I love the fact that people are talking about this a lot, because I think, again, like, I really think it's important to, whatever we're doing around wildlife, is that we want them to be able to maintain their natural behavior. And I think one of the key things is for each species is that before you actually go and use a drone, is to at least do some observation first, launch it and see, record, how high, what drone platform are you using, what parameters are you using in your flight pattern, are you hovering over an animal, or are you just passing over, fixed wing, multi-rotor. A lot of the small drones are really not that noisy. Like, once they're at 50 meters height or so, they really are not that noticeable. And there's an increasing number of publications out there. I'm actually in the process of writing a book chapter on this exact topic. And it's been fascinating actually looking at the research that's published out there. But I'm aware that there's a lot of stuff going on that people are doing, which is awesome, that's not yet published. And so I put out a little survey at one point, and also just got people's experiences as well, to try and capture a broader range of our knowledge in this little piece that I'm writing. But like, there's an example where some people were studying seals on a rock ledge, and they initially started, or they started high, and then they actually came down until they just watched the animals until they saw a reaction in those animals, and then they made sure that they always kept above that. They used different platforms, and some of them were noisier, and so they wouldn't use those platforms. So I think it is really important to determine what is the best drone option for the application. But there's also, of course, the famous research about the bear that got disturbed by the drone, and the heart rate. So the actual visual response or the behavioral response was not really there, but physiologically it was having, like, really getting quite anxious. And it was a very interesting study, and I think it just makes you all aware that you have to, even if it doesn't respond in that way, in a behavioral way, there can be some other physical impact on them. So the further away you can do the thing, the better, essentially. But I think as well that I've had a look at some of that research now, and that I think they flew the drone within 10 meters of the bear, and I'm like, I just would never even do that. So I think, like, have a look at the detail of what people are actually doing. Like, look at the methods. Would you consider doing that if you're trying to study a natural thing? But obviously, maybe they were trying to push the boundaries and see, if how close you could get or something. But, there's a plethora of videos online of inappropriate use close to animals, and in my mind, it's unacceptable. And what I find interesting as well, I've been talking to cinematographers and the like recently as well, and they don't have restrictions really. Like, no one is saying you have to keep a distance. Like, they're there to get a great shot of this animal. And yet a wildlife researcher who wants to monitor a population has to have ethics approval. They have to comply with all these things. And yet a cinematographer can just do whatever they like. And so people are just going, oh, I'm just doing a video, I'm just doing some visuals, instead of saying that they're monitoring, just so that they can not have to go through that process. So, and I think that's okay if everyone's responsible, but that it's not going to be the case. And so I think that's something to be wary of. And certainly there could be more, if we can make more information available, readily available to people, and just let them, alert them to the fact that what you're doing is actually stressing that animal out. I saw some footage recently of one of the endangered gliders here in Australia, and I kind of like, and when are you going to turn that massive spotlight off this poor animal who can't see? They can't glide because they're blind. I find it quite confronting. So I think it's something that we as a community need to sort of, continue to promote, and responsible flying.
Yeah. When's your book chapter going to be coming out?
I'm not sure. It's due now, so I have to finish it this week. But I'm not sure what the publication date is. But you know, I can keep you guys posted.
Let us know when it's out so we can at
least. It's supposed to have an Australian focus, but there's so much knowledge around the world. I'm like, well, it's going to refer to research from everywhere. So yeah.
Awesome. One last question, because Isla and Phoebe kind of have similar questions. Isla, are you still here? Okay, I'm going to ask. Isla was wondering just about, they were both wondering about cost. Phoebe was asking, sorry, Phoebe Jordy or Isla? Sorry, okay. So Phoebe asked a similar question to above. I was wondering if it might be possible to purchase rather than hire for long-term tracking projects. We track animals for 2+ years, and if so, what the approximate costs are. And Isla was asking, I was wondering how many have been made, cost of hiring, and whether there is an intention to be able to sell them to researchers. So.
Yeah, so at the moment, yeah, we do only hire them, and there's a couple of reasons. One is that the technology is advancing like pretty much every week at the moment, and so there's always improvements coming along. And one thing that when we first started looking into all of this was, you know, when people buy their drone and you spend 20 grand on a camera or 30 grand on a camera or something, and then it just sits on your shelf for most of the year, how much value are you getting out of that? And so one thing we also like is that by hiring, we actually we're more in touch with our customers, and so we can, like, we provide a lot of technical support. So if someone's having an issue, they just give us a call or send us an email, whatever. We can look at their data and help them interpret it if they're having any issues. So we like to really provide that sort of quality support as well, rather than just kind of selling a product off. They're not cheap to produce, and so by hiring it actually is a more cost-effective option. And we also, if it's a long-term project, one of the great benefits is that you can actually we will replace the system if you do multiple 12-month hires, for example. We'll actually upgrade your system every 12 months, so you will always have the latest technology. So I think that's a key benefit if you're doing these projects over a long time.
Okay, we have one more question.
Okay.
Sorry, I managed to get the mic working. One of the questions was just thank you, Debbie. It was a really great talk, and I think you're doing amazing work. What is do you mind telling us what the cost price is of a unit, and how many units have you got? And then also, just quick question is like what's the approximate cost for hiring one for a month as opposed to 1 year?
Yeah, sure. So we have our, well, to start with how many we have. So we only have a small number at the moment. So we have around 30 systems that we have built. They're all handmade essentially at this point, because we haven't really gotten to that scale where we can really manufacture things. And they're all individually tested and everything by us as well, in the field as well as in the lab. And the prices do vary depending on the length of hire. And we really only have our prices in Australian dollars at the moment, so I'm not sure how that translates, but it's much less than euros or US dollars. But so, for example, for an international project, we have a 12-month hire, looking at $1,700 for each month, and then for if you had a shorter term hire, it'd be more like $3,200 for a month. So when you look at doing an entire day's work in kind of an hour or multiple days of work in a couple of hours kind of thing, then I think the benefits of the savings of people's time and effort are far outweighed by that. And if you do have projects over longer term, then like contact us and we can chat with you about that. But we actually are able to replace your system for a new one every 12 months. So you will actually always have the latest gear to be able to track with. And one of the other things that we're developing at the moment as well is being able to not only track signals, but also determine whether there is a mortality signal. So if you're interested in survival and just looking at whether an animal is still moving or not, we're actually building up some capabilities to be able to tell that immediately. As soon as you're picking up a signal, you can actually tell what the pulse rate is and very quickly focus in on those animals that you need to get to if it's got a mortality signal.
Okay, I'm facing a revolt in the chat because I missed Pascal's question. Pascal, can you jump in now?
Sure. Thank you. No problem. I'm not sure if mine was the only one that was missed, but anyway, was it? It might have been. Anyway, thanks, Debbie. Thanks so much for a great and inspiring talk. Actually makes me think back and reinstills the excitement, because when I started my PhD at UTAS here in Tassie, back then, Arco Lucy might ring a bell, was one of my co-supervisors, and I was I was really looking forward to using drones for telemetry, but unfortunately it only got to the point where we worked with RFID on bees. So yeah, it didn't extend to the drones.
That's
in the end.
Cool,
anyway. Yeah.
Bees.
I want to use telemetry. Sorry.
Oh, I just think that's fascinating work with the bees and being able to track them. I think it's really awesome.
Yeah. I would have loved it to be to go a bit further. Anyway. I've only used telemetry so far for bats, but yeah, that's where those small NF-denser transmitters come into play. Anyway, the question was rather, I think part of it is already answered, because you said you're looking forward to applying those new antennas. And my question was actually if you had looked at using automatic direction finders. That's a system that's got multiple antennas that record simultaneously.
Yes.
Instead of actually rotating, physically rotating the drone, you could actually virtually rotate the beam just by phasing the antennas differently.
Yes, we did actually. We did dive into that quite intensively for a period, because we also thought, come on, there's got to be another way of doing this. And it worked out. From what we found, and when we did that research, there was lots of costs to doing that. The physical attachment was one of them, having something that was manageable on a drone without interfering with any sensors and not inhibiting the flight in any way. And then the way of dealing with the signals, and it causes. It sounds great, but the practicalities of that processing, we didn't get on top of it. I'm not saying it can't be done, but I think there's a lot of those like tower stations are, have that sort of an arrangement where you can be getting things from all directions. And so that was why we explored it, and we thought that would be awesome. But we found that when we started actually trialing it, that it actually became a bit of a beast and was quite challenging to overcome.
Because that's the second part of the question kind of relates to that. One thing you could do is simply record all of the radio signals, all of the phase quadrature signals you receive. Storage is quite cheap these days and quite fast. So you can actually simply record it and analyze it after the fact. You can actually tune into different parts of the signal and do the direction finding after the fact. And when you've got your GPS signal along with that, you can do quite a bit of sophisticated processing that doesn't have to be implemented on the drone. So that probably
no. Well, in fact, a lot of the actual locating doesn't happen on the drone. So we collect the signals on the drone, and we then send those down to the base station, and that's where the actual algorithms are doing the locating. So it takes away the need for too much serious computational power up in the air. But we actually used to originally capture the whole 2 megahertz band and do just what you suggested. We found that there were other implications of that. For example, the distances that we could get detections and things like that, because you are looking over a much bigger, a wider band. And yeah, so it has evolved over that time, and we found that it was better if we could input and really focus the sampling and the processing. And yeah, you could easily record it and do it afterwards. You don't have to do it in real time, but then you don't know where to go. If you're not getting the data from that first rotation, you don't know where to go to get the next best intersecting thing. So flying blind is really quite frustrating, because we didn't have long range comms to start with. We only had quite short range, and we would often lose connection. We'd fly away. We'd be able to download the data and reprocess it, but it was really clunky and incredibly frustrating, when if you had that data in real time, you could have just made some good decisions and got some results. So yeah, there's many ways to possibly do it. We found that once we got our longer range comms, we get at least 2 kilometre communication distance. It just changed it. Like, it's just great, because I no longer lose connectivity, and I just constantly have this feed, and I can always see what's going on in terms of signals. So we found it really advantageous. Yeah.
Yes, of course. That's actually why I had additionally in parentheses in my question, because I was thinking, maybe you can get some more information out of it than you originally thought, but then
oh yeah, absolutely. And we're actually, I can't believe what level we're at now, like compared to what we did when we first started, how much we can interrogate that signal and how much more information we can get out of it. So it's been quite a journey. Yeah, I'd never thought that I would know so much about this one particular little blip.
Thank you.
Okay.
On another note, I've talked to someone from the Difficult Birds group about Swift Parrots recently, so that's interesting.
Yeah, cool.
Anyway,
that would have been D.
Okay, one last question, which I also missed. I'm sorry about my facilitation today. Oh my goodness. So Melissa is asking, how does the drone work in high winds? What is the max speed you can fly it in? And also, what was the updated flight time after your initial troubleshooting? Did it get better than 10 minutes?
Yeah, sure. So the Matrice 210, it's pretty amazing. It can fly in some pretty serious wind. Probably it's not ideal to fly in really high wind, as you can imagine. If you're trying to get a bearing and the drone is getting buffeted by the wind, your errors are going to be bigger. But basically, if you fly within the capacity of the drone, it's okay. And so I have flown, not that I would recommend it, but it's probably maybe over what the capacity is, but like over sort of 40 to 60 k's an hour kind of winds. But I wouldn't recommend it. I would just stick to whatever the manufacturer says for that drone and do that. But yeah, and the other thing that became evident, I went and visited someone who was using it in a really windy place, and the drone, in order to sort of stay in a stable position, was flying like this, sort of facing into the wind. So if you can imagine, the antenna is sitting on the legs and directional, and normally it's pointing horizontal to the ground. If it's like this, it's either, if it's pointing this way, it's pointing to the sky or pointing to the ground. So it's not ideal to fly in really high wind, but it actually, if actually what you want is just to know that something's there, then that can be enough. Or you can try and locate, and you'll get bigger errors for your results, and you'll just try and get there early before the wind picks up or something. Yeah.
Okay, I'm going to put a wrap there. I know there are more questions. We will follow up in the forums. There is a link to this episode where we can hold a discussion, and Debbie can pick up additional questions there over the coming days. So thank you so much, Debbie. That was wonderful, and thank you for staying around for an extra hour.
My pleasure.
The pale. Yes, and don't forget, next week's episode is around. Ellie's just dropped a link to next week's episode. And we'll see you there. If you do want to stay around, we do have a chat. It's more of a casual thing. We stopped recording, so anyone's welcome to just talk tech and talk more specific, probably about drones, given today's topic. But otherwise, thank you, everyone, and thank you very much, Debbie.
Thank you, my pleasure. Thanks, everyone.
Thank you,
I will follow up
Debbie.
on that forum. Thanks.